I guess we'll go ahead and get started if everybody's ready. This talk is about Microsoft SQL Server post-exploitation. So once you've already popped a SQL Server, and this talk is post-exploitation. This is going to be techniques you can incorporate inside of SQL once you've compromised it. Operating with certain layers of stealth, which is always valuable for pen testers or people just breaking into stuff. The concepts and stuff that I talk about in this talk aren't being incorporated by a lot of people. If you look at most pen testing resources with regards to SQL Server, they all talk about basically the same handful of steps once you've gotten a point of injection or you've found some creds to log into SQL Server across like an enterprise. Like SQL Server, you get your injection points typically from the outside, but on the inside, there's many more resources to harvest. Open file shares, just random development code here and there. And then I'm going to release proof of concept code here. Please keep in mind that this is proof of concept code, so if you go and download my code and you're like, this sucks, you're right, it does. What this talk is not, there are no O-Day vulnerabilities in this talk. Everything that I'm showing you here is stuff that's available within SQL Server. I'm just abusing the architecture in a way that whoever put it together didn't quite intend for it to be used. This isn't a slam on SQL Server. This is just a demonstration of, hey, they left this functionality in, kind of curious about it. We're able to do some interesting things with it. And there are no theoretical attacks and scenarios in this talk. Some talks you sit on, they're like, hey, you know, we're able to do X, Y, and Z, so in theory we should be able to do this. No, everything that I'm talking about in this talk, I've done, either on assessments or for extracurricular activities. The other thing to keep in mind is that if you're able to do any of the stuff that I'm talking about here, the game's over anyways. Like, a lot of people will look at this and they'll say, oh, well, it requires elevated access. You're right. If they can do that, you lost. Game over. And, you know, hey, there are things you can do to lock down a SQL Server and prevent this from happening. This is true. You also shouldn't use a blow dryer in the shower, but they have a warning label on it because enough people are doing it. So, I'm Rob. Just thought I'd introduce myself. I'm really cool. Like, ask anybody who likes me already. I do pen testing for a career. I've done it for the last 12 years or so. I worked at a variety of companies. I guess I'm what you refer to as a jack of all trades. Like, lately, apparently, people are calling me the SQL guy. I'm not the SQL guy. People have called me a web pen tester. I hate web pages. Like, it's just whatever interests me at the time is what I look at. I happen to look at SQL. There was a lot to be found. Had fun with it. So why SQL post-exploitation? Everybody has this concept that once you compromise SQL, go for XP command shell. XP command shell, run commands, create an account on the host. Basically fill up the log file with all this crap that everybody can determine what you've done once you pop that host. Brilliant. There's a lot more to getting into these hosts than doing all that, and sometimes you want to remain stealthy. I know a lot of companies out there and a lot of boutique shops are starting to offer this advanced persistent threat. Hey, we'll mimic the bad guys that have been on your network for 6 months, and by doing so, we're going to sit on your network and just stay stealth. Nobody's going to see us. All right, they might have a use for this. The stuff that I'm talking about here, you go and you try to research, which I tried to did, you know, like got researching. And there weren't a lot of resources on the things I was trying to accomplish. And from some of the stuff that I show in this presentation, none of it was covered. There's even less information out there on detecting this and preventing it. I'm guessing part of that is that nobody knew you could do this, so move on then. More information about post-exploitation and techniques is beneficial. I mean, that's why everybody's sitting in this room here today, want to know more. And then, like, this is a big sticking point for me, is maybe I can get more people interested and writing tools by showing them that there's more interesting things out there to be found, so that they're not just running the tools. Meet a lot of career pen testers these days, and you ask them, oh, so what do you do? X, Y, and Z. What do you use? This tool, this tool, this tool. What do you do when you got to write something custom? I don't do that. Like, what's up with that? So one of the first tactics that everybody gets with SQL is XP command shell. Pop a SQL host, get XP command shell, get console access. It's on every instance of SQL. SQL 2000, you could actually rip it out, remove the DLL. Future versions of SQL, they added these new features of, no, we'll just add some more options that make it so you have to enable stuff. Well, if I have the access to run XP command shell, I probably have the access to set those options. And it's gotten to the point that if you inject on a host, or you log into a host and you have no XP command shell access, you know, hey, there's these 4 steps I gotta do. Then you have it again. And everybody knows about this. So if you do pop a host, and somebody has even the worst IDS or you know, log monitoring or anything, they're watching for this one. This is the big one everybody watches for. One of the other post-exploitation tactics is get the current SQL hashes. Once again, fairly well documented for every version of SQL in every format of the hashes. Even with the new 2012 hashes, everybody knows how to do this. Once again, SQL traces, SQL logging, IDS, everybody's watching for these commands to get thrown out there so they know we got to rebuild this one. Another one that everybody does is try to do a you know, force authentication against another host so they can sniff the hash. This one doesn't really play out too well over time, because if you're running old instances of SQL that are running a system, you're going to get the system hash in theory, which you can't log in remotely with that. You're going to get a network account or a network service account. Once again, can't log in with that. If you're really lucky, you're going against an organization that has set up their SQL clusters with like a SQL account that actually has some rights within the environment. So if you pop that hash, all right, you might be able to move either laterally or escalate your privilege within the environment. But 9 times out of 10, you're just going nowhere with this one. It just kind of gives you that, hey, look what I did, and it showed up in Wireshark, and that's kind of cool. But it doesn't take it any farther. This one is a little lesser known to some people. It's OLE automation, and it allows you to instantiate OLE objects within SQL Server. So everybody uses this to instantiate WScript so they can create a shell. Problem is, the WScript instantiation has no output method. So you execute a command and it's kind of blind. So then you have to instantiate other things, which is what all this script is, instantiating file system objects, so that when you issue your command, it dumps to a file, and then you can read the file, and then you can delete the file, and then you can display it back to you. So all of this goes on, and you have to put in all this stuff, and if anybody's reading the logs, if anybody's monitoring, they're gonna see all this crazy stuff floating across their network. And what's worse is that they can pull all this and just walk it. They can figure out exactly what you did at any given moment because you've scripted it all for them. You remotely wrote a procedure for them. Last one is pilfer the database. All right, I can't go anywhere from here. I can't execute any commands. I'm in an unprivileged account, so they just start going through all the databases, all the tables, all the user accounts, trying the same password, trying other passwords they've compromised. This is one of those that usually yields a lot of information, but for whatever reason, as pen testers, it's kind of on their back burner. And I just want to call this one out because as pen testers, usually you're going for the crown jewels of the company. I don't know of any company that's like, domain admin is the crown jewels. We care a lot about that person. No, they care about the data. So if you do pop a SQL host, don't forget, go for the data. That's what's important. So this is the bit of functionality that everybody seems to have forgotten. They always go after the existing stored procedures. They go after XP command shell. They go after file exist. They go after dir tree. They go after reg read, reg write. All those fun ones that Microsoft put there for everybody to use by default because they were useful. Not a lot of people remember that you can write your own. If you look at some of the early days of SQL security and the lockdown scripts and all the things that we're going across, the ones that they had everybody watching for was SP add extended stored procedure, because you can add them back in. It wasn't just about removing the ones that were there and adding them back in. You can write your own and add them back in. But people haven't been doing that. Like they did initially, and usually for legitimate reasons, but nobody really created like that tool set of stuff you could do in extended stored procedures that was illegitimate. But the concern that everybody had is that extended stored procedures are going away. Microsoft's been saying this. So in 2000, they brought out the documentation on the MSDN. Here's the full API for interacting with extended stored procedures. Then in 2005, they reissued the documentation, but they're like, hey, look guys, this is going away. Start shifting off from this. So people that were using it legitimately migrated away from this. Then in 2008, all right, no, it's really going away. Like, we're not gonna have this API anymore. So people kind of pushed it aside some more. Then with R2, they're like, no, honestly, it's out of here. And it's still going away in 2012. So game on. Like, you can still play with this stuff. An extended stored procedure is just a DLL. It just has some special features to it. It exports specific functions, one function per extended stored procedure name that you're going to have. The function has to be named the same as the extended stored procedure. So if you look at like the default Microsoft ones, you have XP command shell. Within the DLL that it's mapped to, there's an exported function, XP command shell. All these DLL functions do is take in an SRV proc structure that's handed to it by SQL. That proc structure has information pertaining to the session that called it. So if you're a domain account that called XP whatever, it gets some information saying domain user called this, here's what his session information looks like, and here's some other interesting facts about SQL. This function export right here is kind of the base skeleton of what an extended stored procedure can be. This will compile, this will call, and this will return correctly. There's not much to them. The documentation surrounding these is suspect. Everything's there that was initially implemented in 2000, and some of this was even implemented in SQL 7. But some things have changed, the calling conventions, the data types returned, some things just don't work, like trying to get a bind token. Some things don't work as expected, which is kind of the premise of this talk. And finding samples on this stuff is a pain in the butt. Like if you're looking for the Stack Overflow equivalent of show me how to write a stored procedure or extended stored procedure, you're really not gonna find that. These are the base functions that are available as part of that extended stored procedure API. These are the ones that 9 times out of 10 you're going to incorporate into your project, legitimate or otherwise. You're going to make use of these. So you have the RPC params, so you can get the number of params that were passed in. So when you call an extended stored procedure and you include information in the little ticks and separated by a comma, these are them. How many there are, what the values are, and the values come back in param info. You have SRV p field, which you query that to get information about the session specific. Send message, which if you've ever executed a SQL query and you get your column of results and all the data sets, but then there's a little tab over to the side and it's like, hey, this completed successfully, or this broke, or SQL doesn't like you. That's the send message function. It messages outside of the returned results. And then this big list down here, these are all the ones for actually returning the results. Specify the columns, the data types in the columns, and then you start pushing the messages in that are going to get returned. SRV p field out of the entire extended stored procedure API is by far the most interesting because it takes that SRV proc structure that's handed into the function, and then you can call it with different flags specified based off the information you want it to return about the session. So like in this listing you have SRV app name, class ID, network module, all that. So you code all that up, and you can get all this information coming back to you. So you call the xproc, it queries all this information, dumps it back. The information there is kind of basic information. If you're already operating within a session, you don't necessarily need to call an xproc to get this information, but this is useful for the functions themselves once they're operating outside of that session to have some insight as to what's going on inside of SQL. One of the questions that comes up if we're talking about using xprocs is how do we get them onto the system to begin with? And there are a handful of ways. Any of the common pen testing resources that talk about file uploads, they'll be able to cover this. So, stored in the database, if you're getting injection and you have a single field, you can start chunking it in line by line and then have it all merge. But one of the most useful, especially on internal pen tests, corporate environments, things like that, is load it remotely with the UNC share. If you do the SP add extended stored procedure, you can specify UNC share. The advantage to this is it's going to load it remotely off your system. They don't get a copy on disk. If you happen to have to leave quickly or they turn off the system, they don't have a copy of this. Now, if they do a full memory dump, you're kind of boned. But in normal scenarios, you're good with this one. Once again, not a lot of sample code for doing this kind of information. When you start querying, when you go to Google or Bing and you start asking for extended stored procedure information, one of the first ones that's going to come up is XP Hello. That was like their hello world. You call it and it comes back, hey, talk to SQL, awesome. And you start digging deeper and you'll find these samples of XP Hello, SP Serve Param, and all these others. And then you can start playing with them. Now, XP ODBC.C was one of the really interesting ones because when you start playing with extended stored procedures, you're left with this notion, hey, I can get everything about the session, I can get the username, but how do I log back into SQL? Extended stored procedures aren't terribly useful if you execute them and they run off and they do their own thing and they can't get back to SQL. Also, it doesn't seem very feasible to hard code in a password. That's just bad form and kind of asking for it. And you don't want to hand in parameters like logins and passwords into extended stored procedures because if somebody's running a SQL trace, they're going to see that come up in the log file. So looking at ODBC, we see it connects back in using this flag SRV PWD, which if we go back to the initial listing of all the flags that were valid for coming in to SRVP field, that one wasn't even listed, which was kind of interesting. The ODBC.C and all the other samples originally shipped with the SQL 2000 dev tools, like the dev samples and everything like that. These files have since disappeared in newer iterations of SQL. So getting your hands on these has become a challenge in and of itself. Not to mention that the function calls that they use within this file to connect back into SQL are using legacy libraries that you can't use in Windows anymore. Some of the functionality just isn't there. They've updated the libraries, just everything has changed. So in this one, we see that they use SRV PWD, which is kind of interesting because they're requesting, hey, I want a password value. Comes back out what exactly is coming out of that function. Once again, not listed in the MSDN. It generates this huge long hash down here, which doesn't map to the SQL hash. Like if you dump your SQL hashes, there is no amount of this hash that represents that in any way. So after you start playing with it for a while, you realize that in their code, they're constructing a DSN, they're requesting this SRV PWD field, they're getting back a value, and they're handing that straight in as a password, which means this huge long hash, which looks cryptic and unbreakable, doesn't have to be broken. That's the password. That's the plain text of what you need to use to log into SQL. What this password is a temporary session password for the account that called the procedure. It's valid until a call to that function is made again. It's valid until the session that called it goes away, or until SQL restarts. Any of these go down, password's no longer valid. But the password's unaccounted for. Like, it's not gonna appear in the user table. It doesn't appear in any log anywhere. It's just kind of this magic password in memory for the session that called it, so you can start logging in with it. The other awesome thing about this is if you use one of these passwords generated in one session, you log in using that session's login account and this password. If that session goes away or if that function is called again, your session's still valid. Provided SQL doesn't bounce, your session is still completely valid. So using that, just from a pen tester's perspective, we can make this useful. If we have some form of blind injection to where we can execute SQL commands in a privileged context, load an XProc remotely, call this, and send back a password, then we can log in and now we have console access, which anybody doing a pen test knows that this is infinitely more valuable than shoving all your commands through a web page, usually because that comes down to some amount of automated scripting, things like that. So created a video demonstration with an XP, or extended stored procedure, that illustrates this type of methodology. Any of the sample code or any of the samples that I show here today, they'll be available for download, so anybody can go play with them and do fun things or bad things or interesting things. So this example uses Wireshark, Notepad, and just the calling session. Go ahead and start a Wireshark sniffing session. Come in here, and this XProc takes a single parameter, which is the host you want to ship that password off to. So go ahead and execute that, go into Wireshark, and we can see an ICMP request was made. That temporary password was padded into the ICMP data. So we can just, in Wireshark, copy the strings out of that packet, dump it in a Notepad, and then it's right there. You have the account SA, and then this huge long string. Copy that string, kick off another instance of the management studio, and this is all while this is executing. There's a delay in the procedure so that the session doesn't end, and then go ahead and dump in the password, and it logs right in. So it's kind of a useful utility for that aspect. But when you look at SRV pfield, you realize that that wasn't in the listing on MSDN. They had all the other fields, but not that listing. So it kind of stands to reason maybe there's some other stuff that this function is going to support. So you go into your development environment, you go to that value, and then you pull it up in the header. And suddenly we're presented with all these other values that this function supports, all these other flags that we can request different types of data out of SQL. And then the most interesting being SRV underscore hash PWD. That one, you look at it and it's like, that's kind of rad. I want to know what that's about. Show me more. So it did really seem too good to be true. So instantly created a project to dump that hash in there, or the SRV hash PWD flag. Function returned with no errors, but no data was returned. So it was just kind of failure for all, not happy times. But there was still other things within that header file that wasn't documented that we had the ability to play around with. Most of them behaved as expected. Some of them just didn't do anything. Then two flags didn't work, period, with SRV pfield. They returned errors, no data was returned. The function just kind of blew up when you hand these in, which was the SRV message CLID and the instance name. So, go and Google those, and these were actually documented. But they were documented for a different function. They're documented for SRV pfield EX, which anybody who's familiar with developing for Windows knows that for a lot of the APIs out there, there's the base API name and then there's an EX, which gives extended functionality. EX, in this instance, didn't provide extended functionality. If you took any of those other flags that were valid with SRV pfield, pass those in, you didn't get anything back from EX. So it wasn't like it was inheriting the parent and just adding some extra functionality. This was a unique API in and of itself. They just chose a poor naming convention. So realizing that these two functions are over to the side and part of this other API, they were all chunked together in the same header file. So we had these other flags for a new API that were over in the header file that didn't work with the original P field. If they didn't work with the P field and the X, then we had somewhere to go, because we had this other one, SRV hash PWD, which didn't work with P field, but maybe it did work with the EX function. So, to the IDE and create a new project. When I ran it this time, the buffer was returned, and there was actual data in the buffer. The byte values in there, I went ahead and converted those to text so I can get an output, and sure enough, the SQL hash was coming back. So now within an extended stored procedure, you could query that session's SQL login hash. And the cool thing about this is it didn't show up in any of the logs. Typically, when you're dumping the SQL hash, you have to query the system table. Not in this case. In this case, you can call an extended stored procedure. Now, in the log, somebody's going to see you create this extended stored procedure, and they're going to see you execute it. But because of the way SQL Trace is set up, they don't see the values that come back. Not only that, because we're writing this ourselves, we could mangle the output however we wanted, so that the moment we had our hands on it, then we could decrypt it for what it actually was. So knowing that we can take an extended stored procedure and get the calling session's SQL hash out of there, we can go a bit further with it. Gone over this stuff already. So when we consider some of the functionality that's available in SQL, we know that we can impersonate other SQL login accounts. This is it's a privilege that can be granted to individual users in SQL if they need to impersonate other users, or it's just one of those bits of functionality that things like SA and other privileged accounts can do on their own. When you do impersonation in SQL, you have effectively become that user. You're not just executing commands on their behalf, you become that user. So keeping that in mind, we can get a list of all the SQL names from the SQL Server. You query the user table. You don't have to query for the hash right there. You can pull the SQL logins, or you can look at who's logged in. You can look at PID owners. There are different ways to correlate what the SQL login accounts are. Then you can impersonate each user one by one, and then call that hash function. And then basically you've got all of the SQL login hashes without querying that table, which means if somebody's monitoring the logs or they have an IDS in place, you've just gone past it because you're not doing it in any conventional fashion. So with that in mind, I, of course, ran out and created a function to do this. So I created a single extended stored procedure called getHash, which just dumps the calling session's hash. And then going from there, have getHash, and then just kind of illustrate over to the side. You get that, it gets your active session hash. So knowing that that's the case, we can go ahead and architect a stored procedure that does all the work for us. And all the stored procedure does is get a list of the usernames, impersonate them, call that, dump it back into a temporary table, print it out for our viewing pleasure. So go ahead and created the stored procedure, and then now we can execute the stored procedure. And you get all the SQL login hashes. Once again, this is done without triggering logs, without anything truly indicative of what we're accomplishing in SQL showing up for anybody to know what we've done. And once again, you have the ability, since you're in control of this XProc, you have the ability to ship that data off. It doesn't have to get displayed back in SQL. You could do same functionality as XP SendMail if you want to just mail them out, or you can have them hit the disk, or different exfiltration tactics using DNS to ship them off, like however you want to go about getting your information. One of the interesting things about the XProcs is that when you execute them, they're running in the context of SQL. So if you have SQL set up as system, really bad idea. But if you have SQL set up as system and you execute an XProc, it's running as system. If you have it set up as a network service account, it's running as that network service account. And if you have it running as just a regular average user, like they recommend you do in all current versions, that's the same, same rules apply. But when you execute these XProcs, you're executing in the SQL process. So you have access to everything in SQL. Now, in SQL, you can have that mixed mode to where somebody can log in as a domain account. They've factored that into the API. You can call SRV impersonate client, and then you can impersonate that client that is connected in. So if you need to carry on any actions on their behalf, you have that ability at your disposal as well. But the main thing here is from within an XProc, we have access to SQL, all of SQL's memory, all of SQL's resources, everything that the SQL Server itself is, we're that as well. Which means we can look through memory, we can manipulate that memory, and if we're operating in the memory space of SQL and we're screwing with SQL's memory, this isn't getting logged because these are the internals. This is the stuff that users aren't supposed to be doing, but we still have that available to us. So if we look at SP password, which is used to change login account passwords in SQL, we can see that it always comes down to the same set of commands, alter the login password. That's good iced tea. So we have a static string to search for in memory if we want to start looking for more fun stuff. So searching for that string, we can see when a password is altered in memory. In this instance, they're changing the password for SQL user 1 to new SQL password. Not terribly complex, but illustration of what you can find in memory. Now, if you have a one-off SQL server that you're using for testing your little web application or something, doesn't have a whole lot of users, you're probably not going to use this because when the command's executed, it kind of gets cached in memory until more commands start rolling in and overwrites it. But in large enterprise environments, you're going to see this quite frequently because people should be changing their passwords regularly. So, using that, create a tool. So all this XProc does is when you execute it, runs through memory, looks for that alter password, and just starts, sniping the text out of memory of what was corresponding to the alter statement. So here we have our base SQL session that is going to execute the XProc. Over here we have another session. So we take SQL user 1, go ahead and adjust their password. Another session over here. This one's going to run through and change the password for SQL user 2. Is it displaying okay up there? Because it's like changing resolutions is kind of tricky. And then changing for SQL user 3. Then we go back to the initial session where we can execute this. All these sessions were treated differently to illustrate that it's not in the same space. We're not in the same session. And then it's run, and it's hard to see on my screen, so I'm assuming it's even harder up there. But there's the plain text password for each of those accounts as they were changed. They're just still sitting in memory. Now, I have actually talked to MS about this. Because I'm a nice guy, I don't know. But I talked to MS about this, and in 2012, they actually addressed this specific concern by obfuscating this in SQL memory. The downside being that if this comes across a socket connection or a named pipe, it's still buffered in memory somewhere, and they have no control over that, so you still get this result. So if we're operating in SQL memory, and we can access SQL memory, and even the master database is mapped to memory, it stands to reason that we can start doing some fun stuff there as well. So we can swap out hashes in SQL, and it's very easy to do because we can calculate new hashes because they give us this undocumented function, which David Litchfield went on a mini crusade to say, hey, there's undocumented stuff. And this was one of them that he pointed out, and he used it in a lot of his scenarios. But we can calculate a known password in SQL. So the plan here is generate a hash, get the current hash, which we already have the ability to do, swap the hash in memory, and sleep a little bit while somebody runs back in to use the known hash, and then put things back the way they were. Because, I mean, you don't, somebody's going to notice. You can just be a bastard and change them all, but that's, you know. And once again, because you didn't go through legitimate means to change these hashes, to change these passwords, none of it gets logged. The specific scenario where this really comes in useful, once again, is you're operating through an injection point or through an application to where you can issue these privilege commands to load the XProc, but you don't actually know the password. Or you were just magically dropped into SQL, but you have no means to actually log in legitimately. You do this, and suddenly in the logs, it shows the account logged in. They had a valid password because at that moment in time it was. But that's kind of the plan of attack there. So of course, new idea, new tool. So this actually follows that exact methodology. We can go ahead and log in. The password for the SA account at this moment in time is A, so you're going to see a single character hit. Then we go in and bring up a new query session. We're going to generate a password. And the password being generated is from the plaintext password, I believe. Told you, hard to see. Set pass. So now we're going to take that hash value, just copy it on up, execute the extended stored procedure XP swap hash. And we're going to swap in this new hash that we've created using the password hashing algorithm, and execute that. And when that executes, it's going to swap the hash and wait for a period of time before swapping them back. So we take a new session, SA, and now we're going to use that new password, not just A, but you see all the little dots go in, so slightly different, and it works. Then we can go back to the initial session. This will take a little bit of time to return, so I'll skip ahead. But when it returns, the output of the message is found a hash in memory, found a hash, rewrote hashes, slept, replaced all the hashes with the original values. So using this, we can start logging in and out of SQL using our known values as opposed to their actual passwords. So what we've done so far is we can execute code in the context of SQL. Execute code in the context of integrated authentication accounts using the SRV impersonate. So if an account logs in, the XProc can execute on their behalf. Get a temporary password for authentication, get the current SQL login sessions password hash. Get plaintext SQL logins using the walking through memory for the alternate passwords. Get all SQL login hashes without querying the system table, and swap those login hashes so we can run off and lock things down for people because we don't want to do bad things. But all of this is based off SQL logins. Like if somebody logs in with a Windows domain authenticated account, we're kind of out of luck at this point because all this is based off those SQL hashes that are sitting in the master database. So what about domain accounts? We know SQL has the ability to impersonate people because of the impersonation function. While operating in an XProc, we have access to all the things that SQL has access to. Windows in and of itself provides a means for impersonation. You can impersonate name pipe clients, and with the inclusion of some new APIs in Windows 2008, you can impersonate socket clients. Both of these functions require handles, which if we're operating in an XProc, we don't have. So, you know, I was talking to some friends, and one of the friends I was talking to is HD Moore, and I was just like, hey dude, I got this problem, I want to do this thing. And he's one of those really cool people that if you're like, I got this problem, I want to do this thing, he's like, how about this? And he, you know, contributed to Metasploit, and because of that, hey, I got a problem, can you help me with it? He, you know, kind of gangster. His suggestion was to brute force handles, which not far-fetched because get a D word, the maximum value of a D word is all the possible handle assigns that you can get in a process. What's really cool is Windows has this API, get handle information, which if you give it a valid handle, it's like, here's the information. If you get an invalid handle, it says, no, that's just invalid. It doesn't die, it doesn't kill the process, it doesn't do anything bad. So you can sit there and iterate through and find handles. You don't know what types they are, but you can find handles. And the other cool thing about Windows is with connections, they like to pool those. So you run through memory, be like, nothing, 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 handles. Nothing, 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 handles. I found like this nice little sweet spot that if you go more than 10,000 handles and you haven't hit another, you're probably outside of the bounds of assignment for the process. Not always the case, but it's just good rule of thumb. But HD gave me this API, and he's like, here, do this. And I was like, cool, what happens when I find a valid handle? He's like, I don't know, everything breaks. All right. So I had to roll through and start looking at all the handle API functions. And I found two really cool ones. Get socket op, which is a pretty common one, which gets you socket options off a socket handle. Everybody in code refers to it as a socket, but when you see a socket specifier, that's just a handle. And then get name pipe client computer name, which give it a handle and it'll give you the computer name for the client that's connecting over a name pipe. Now if we go back to SQL, remember there's 3 ways to access SQL: name pipes, sockets, and shared memory. Shared memory doesn't usually happen from a remote client, so we have sockets and name pipe. From there, if we know each one, we can call the corresponding API to impersonate those people. New tool. So impersonate handles, kind of misleading if you go and you look at the source. There's an area in there for sockets, but because that's a 2K8 function and it's not going to work on your legacy stuff, that's all commented out. So for the purpose of this demo, it's just name pipes. So we have our XProc set up there. And if we execute it right now, nothing comes back. There are no handles from remote clients. So go to another computer. And my little testing scenario, this is actually a domain controller. Don't connect to SQL with a domain admin account. Just bad things happen. Like, don't. But in this scenario, integrated auth, we're going to set it to a name pipe for the purposes of this test, and then just go ahead and connect in. So this is connecting back to that Win7 instance. Log in, you get a session, execute a command, call the version. Awesome. You know, we logged in, we can execute commands, life is good. This is just illustrating the window or the SQL 2005 instance that's running on that Windows 7 machine. Come back, run our XProc at this point, after the connection has been made and everything. And in both of these, all 3 of these, we've successfully impersonated the domain admin that connected into our SQL instance. So we have gone from an unprivileged SA account, and I say unprivileged because yes, SA is the top of the line when you're in SQL, but when you take that and you remove it and you realize where it sits on the host, it's just some account in an application, because that service can be running on that host in like the lowest possible context available. Not only that, it doesn't have to be, you know, domain aware, anything like that. It's just a service running on the host. So going from SA, which has no type of meaning within the domain itself, and impersonating a domain user, that's really bad. Or really good. wherever you want to take it. So now we can start using SQL as an attack platform because we have the ability to operate with minimal logging, minimal detection. We can manipulate credential sets. We can harvest the SQL accounts. We can impersonate domain accounts. We can run arbitrary. I really like that term arbitrary because everybody throws it out there. An attacker can run arbitrary code. It's not arbitrary to the attacker. Somebody knows what it does. We can encrypt or mask the data sets returned because we're in control of the code. It doesn't have to come back human readable. I've used, I would say clear output in my examples, but because of resolution issues, not so clear. If you can somehow like wrap that into one of your attacks, that'd be kind of brilliant. Here's the data, it's horrible resolution. We can store data as needed. We're operating in SQL. That's what SQL's for. We store data in a database. And IDSs, AV, all the stuff that's built to like stop bad people from doing bad things, they're completely unaware of all this that's going on. I know this because I've tested it. So why would we hop outside of SQL, which isn't a lot of people's methodology? Hey, you pop SQL, you get XP command shell, create an account on the host, make it, if you can, make an admin account, then log into the host. Well, now we've just left all kinds of trace evidence that we were ever there. Whereas if we go this route, at most we're leaving a few SQL session instance in the logs. We're showing that we added an XProc. They don't know what it does. They have no idea about that. So we really have an awesome environment in which to operate to go and attack the rest of the environment. So I had built out an XProc here to do a reverse shell, but because of system issues and stuff like that, like I have no video to show you for that, so we'll just skip right past that. So now we can use XProcs to execute our code, but they don't necessarily play out in reality as being a good attack platform because for every function we want to do, you have to have a new XProc. And if you keep them all in the same DLL, that DLL starts getting exponentially bigger. And then for every XProc you're loading, you're putting another XProc ding in the log file, you're putting another one in the system, you're starting to do things that are going to get you noticed. And the initial setup and teardown of this just starts getting unmanageable. You add an XProc, you add another, you add 10 more. If you're going to leave that host, which compromising hosts is kind of like going camping, leave it cleaner than when you arrived, like that becomes a pain because then suddenly you have to start tearing out all these XProcs when you leave. So the solution is that we make the database work for us. We create a single XProc. We can store binary code in a database. There's data types for this. There's binary blobs, var binary. There's all kinds of large data value sets that we can throw into the database. So we can start loading our attack tools into the database itself. Added advantage, it doesn't hit the disk, especially if you use a temp table rather than a global temp table or an actual table, because that just stays in memory. So you can start loading all your attack tools into the database itself, and once again, nobody's really going to flag it for anything. It's not going to show up on disk. They're not going to see it execute. It's just sitting in a database table, unless you have some really awesome AV that's crawling your database, and for stability reasons and performance, I don't know why you would do that. Nothing's really going to see it. And then we can also store this data in an obfuscated format. We can store this data in an encrypted format because we're the ones controlling the data. We're the ones pulling it out. We're the ones making use of it. So what I created with this tool is XP Load Library. What this does is it's an XProc that runs, and when it executes, calls back into the database to a table we specify, pulls out the binary code in DLL format, loads it into memory, not using load library because that gets flagged, just loads it on its own, and then executes the code, gives us the results. So in this instance, just have the malicious DLL sitting on disk. You can have that DLL sit in a remote host. You can have it on a file share. You can upload it to the database yourself. However you decide to get it in there, you're good. In this example, I just do a bulk insert from the file on disk and just stick it in a global temp table. And what I've done is modified that the impersonation extended stored procedure so that it can be called from another DLL. And then what XP load library will do is load that DLL, hand it that SRV proc structure so that it can communicate with SQL on its own. Then it can do whatever it wants to do, come back out, and then this way we've loaded a single DLL as an XProc. Everything else is loaded into the database as just table data. So went ahead and executed it, came back with the same results as the impersonation did before. And then to clean up our attack tool set, we just go ahead and drop the table. Let SQL clean it up for us. We don't have to go in and individually pull out each DLL, each function that we wanted executed. Once again, this will be in the sample tool sets, but there's no video for this, is that if we do get lazy and we don't want to write our own attack tool sets, in this instance, what I've done is create an extended stored procedure that will load the metserv DLL for you, do a connect back. That way you have Metasploit access from an extended stored procedure outside of SQL. So just to recap everything, is that we can execute code in the context of SQL, execute code in the context of integrated authentication accounts, get temporary passwords for authentication, get the current SQL login sessions password, get all login session passwords, run through memory for impersonation, harvesting of creds, harvesting of plain text, load attack tools from inside of SQL, impersonate domain accounts, clean up our tool sets easily, and make logging, monitoring, the paper trail just kind of a nightmare to try to follow, which I don't know if any of you guys do forensics, but I know you love that aspect of the job when there's just nothing there to deal with. And then we can load existing tools if we don't feel like writing our own. So, any questions about any of this, all of this? Yes, sir.
I don't know when you're changing the hash. Do you know if there's any kind of group policy, domain policies applied with, could that circumvent and not have to deal with any kind of password policy?
So so when you're swapping the hashes in memory, that's a SQL login account hash. It's not a domain hash. When you're swapping the hash there, since it's the SQL only, and you're going around the rules of conventional password changes, yes, it completely skirts any policy. And also how I showed you swap the hash and then we swap them back, it's because part of the hashes that are sitting in memory is actually the master database file. They map it as a memory view. So if you swap them there and then don't swap them back, you've changed the password permanently, and there's no log of it in SQL. Any other questions?
What about database monitoring tools like Hedgehog, things like that? Any logging that will catch this?
So all the logging tools that I've tested against to date, they will flag that, including SQL logs themselves. They'll flag, hey, somebody installed an extended stored procedure. Did you really want this to happen? If somebody's monitoring those logs and they're savvy to it, yeah, that's going to seem out of the ordinary. The interesting fact about SQL Server logs, not third-party logging, but SQL Server logs is when you do this, there's a little line politely says, hey, somebody installed an extended stored procedure. That's good to know. But if it has an invalid version number to that XProc and all bold letters, and the version number is wrong because you care about the version at that point. So that's also been indicative to a lot of other tools that I've seen, and that people don't seem to value adding extended stored procedures into the database as being this hugely horrible thing. But if you execute XP command shell, which a lot of people in a lot of environments have legitimate reasons to do, XP command shell raises flags, raises alerts, kills connections, blocks people. But if you add an extended stored procedure, they're just like, oh, this is nice to know.
So given that you've already lost, that's the one kind of like
Yeah, no, in this scenario, you've lost, but rest assured, you've lost big. So, it's, be the best.
That's the only thing to watch for with this one, the only takeaway of how to protect against this.
Currently,
Not getting out in the first place.
right. Outside of not losing the battle to begin with, if you see somebody add an extended stored procedure, assume it's the same as this unknown connection was connected to your DC for 5 hours and you don't know why. Yes, sir.
From what I understand, what you're doing with extended stored procedures is you're allowed to actually write your own C code and execute it.
Yes.
So I can essentially use the Win32 API, so I think you're like using like read process memory to read process memory, right?
Yeah. You.
Process memory, I can do DLL injection, I can do all the other fun stuff.
Yeah. All the stuff you can do with unmanaged code, and I'm just gonna asterisk right there. All the fun stuff you can do with unmanaged code, you can do from an XProc. Now, all the fun stuff you can do with managed code, they went ahead and added assemblies. So, pick your poison. Any other questions?
I had a comment.
Mhm.
I wish I had known about that little loop that you had to go through all the handles. Because I was writing a project similar to that, and I realized, oh my God, there's like 100,000, there's a million different handles. This is going to take forever.
Yeah, no, and that's why I had to credit HD, because I was up really late. He was like, no, go do this. I'm like, all right, dude, I'm putting your picture messed up in a PowerPoint. It's like, cool. Any others? All right, this is just a short list of resources for either stuff that I've kind of pulled out during this presentation or shown or anything like that. All the sample code in this presentation will be available on our website. It should be propped up there tonight. And there was a whole bunch of code that didn't make it into this presentation, so I'll be propping that over time. I'm not trying to entice you to come back. I'm just saying, it might be a resource over time. Yes, the videos will be there. The presentation will be there with the videos in it. And I'll also, just to not put everybody else through the hell that you guys went through, I'll upload like the high-res videos so you can view them as they're intended. And yeah, once again, thank you for showing up to the talk. I'm Rob, and if anybody has any questions throughout the weekend, I'm going to the bar. So you'll find me there. Yeah, I know. Like, I was complaining to him. I was like, they just totally made me a liar in my slide deck. But if you pay them enough, they'll still serve you.